We're going to continue to look a little bit at the concept of color associated with stars as we look at the way in which we have come to our modern stellar classification system, how stars are classified. So pages 18 and 19 are just a few of the contributors to the modern day system that we use to catalog the stars. I'm just going to give you a brief highlight and overview here. Starting with this first gentleman, we have William Wollaston. So you want to jot down Wollaston. And he happens to herald from the United Kingdom, and specifically the country of England within the United Kingdom. And what Wollaston is recognized for in terms of the classification of stars is that we eventually ended up classifying stars by their stellar spectra. So I thought we should start by giving credit to one of the first people we're aware of through his scientific journals that noticed these spectral lines in stellar patterns. So what you want to have with Wollaston in your notes is, of course, his last name, and that he noticed these dark lines between some of the colors in the spectra. But this wasn't his area of research in science, so he didn't pay much attention to it. He didn't try and further investigate, were these patterns always consistent? Were they something that could be used to determine more information about a star? And here's a look at our own sun spectra. And here's a piece of the moon dedicated to Wollaston, not so much because he made note of these lines in the stellar spectra, but more for his other accomplishments associated in the world of science. Continuing on our very quick look at stellar classification, we have Gustav Fraunhofer. He is indeed from Germany. And this is a pretty cool representation of the German flag, as it's a photograph of someone who took water and put dye, kind of like food coloring, into the water in these stripes and captured the flag of Germany. Any volunteers to do the U.S. flag? I'd volunteer for the stripes, not so much the stars, would be kind of difficult, but a real clever way to represent a nation's flag. So you want to have Fraunhofer. And what he's noted for is a couple of things for us in astronomy. One, that he invents the diffraction grating. That is the plastic, in most cases plastic, where lasers are used to etch in a tremendous amount of high lines into the grating so that you can have light be diffracted, hence diffraction grating. And this is where we demonstrated the laser light could be spread out. And he rediscovers the spectrum had fine dark lines. Rediscovering in the sense of he began to pursue a little bit more into the cause and patterns of these dark lines. He wasn't the first to make note of them, as we just noted that Wollaston did. And here's a better look at the sun's spectral lines. Fraunhofer's piece of the moon, named after him in honor of his contributions to science. This next gentleman should be familiar to you, and that is Christian Doppler, the Austrian, who recognized that your spectral lines can account for the motion of stars, whether they're moving relatively closer to us or farther away from us. And this is something we went over in the A Little Light Astronomy, so Doppler being featured here. But because we're dealing with spectral lines, once again I wanted to refresh your memory and be sure he's included in the discussion of information we can gain about stars by looking at their spectra. The Doppler portion of the moon. Maybe I'm showing you the same portion of the moon over and over. Now, I'm actually showing you the pieces in honor of the scientists. Angstrom, he is from the country of, what I have found over the years when students don't know where someone's from, their number one guess they always throw out is Sweden. The number 2 guess is Switzerland, something about the SW countries. So he is from Sweden. And Angstrom, in relation to stellar classification, is the individual who started to recognize that there's an absolute relationship between these, what were dubbed Fraunhofer lines. They're sometimes called Balmer lines, hydrogen lines, and of course very generically spectral lines. He discovered this relationship between those spectral lines and the hot gases of the stars. So starting to put more of a picture together of what these lines might mean. And then just to refresh your memory that the angstrom is the unit that we use for the wavelengths that are measured in our spectroscopy world. So when you look through the spectroscope and you see the numbers at the bottom usually of the measurement tool inside the spectroscope, they're measured in angstroms, named after, of course, Anders Angstrom. We have Kirchhoff, Gustav Kirchhoff, and he is a fellow German scientist of Fraunhofer. And what you want to jot down for Kirchhoff is how he started to get a little bit more specific in realizing the cause of these spectral lines. And the dark lines are caused by absorption of particular wavelengths as the light passes through a gas. So that's what you want to jot down. Then as the cause for the spectral lines was starting to be better understood, it was suggested that it might be possible to identify the chemical composition of distant objects like our Sun and other stars. Kirchhoff's Piece of the Moon for his many contributions to the world of science. Rounding out the page here with Kirchhoff's research assistant, and that would be Bunsen. Many of you are familiar with the term of Bunsen associated with Bunsen burner. You want to jot down the surname of Bunsen. And he recognizes that all elements, so items on the periodic table, all items emit and absorb a unique set of wavelengths. We looked at a few of those in our spectroscopy presentation and notes, like hydrogen, helium, carbon. This is Kirchhoff on the left and Bunsen on the right. And this is Bunsen Honeydew of Muppet fame. Good old classic Bunsen and Beaker. Beaker, his lab assistant. So Kirchhoff was looking at the causes for these spectral lines, and he needed a more permanent source of flame for him to be able to look at the specific gas compositions, for him to better understand those black line patterns and why they were occurring. So you see a spectroscope here, the classic prism, and through his collaboration, Dr. Bunsen was able to develop this Bunsen burner, as we now would call it, where a permanent source of flame was available to be able to put different specimens, different elements into the flame and start to recognize those spectral lines. Bunsen, I must tell you how excellent your study of chemical spectroscopy is, as is your pioneer work in photochemistry. But what really impresses me is that cute little burner you've come up with. So he is considered by many the father of photochemistry. And yes, indeed, he is very classically associated with his invention of the Bunsen burner, but he did quite a bit more than just create a lab apparatus. So here's a Google Doodle in honor of the 200th time his DNA went around the sun, and the Bunsen section of the moon. This will take us to the top of the column here with Father Secchi. Secchi was an avid amateur astronomer. He was very dedicated in documenting the stars that he saw at night. He would record their spectra, and I'll show you in a moment his spectral sketches that he made. And he began to start to organize the stars that he viewed at night, and he put them into 4 categories. You don't need to jot these down, but he put them into categories you see here: white, yellow, red, and deep red. What you want to associate with Father Secchi in your notes, though, is that he's one of the very first scientists to state authoritatively. So that doesn't mean to state aggressively, but with some evidence that the sun is a star. One of these evidence is certainly going to be the establishment of a spectra, that look at all these stars out there that give these spectra, and look how the sun would fit into that pattern. What's sad is many people today, and using the term many, not very scientific, but there are people out there who do not realize that the sun is a star. Many people do label it a planet, and want to make sure that not only give credit to Secchi for being the first one to establish the sun as a star, but the fact that more people need to be solid in understanding this today. Speaking of preconceptions that ideas have, the sun is a big ball of fire. Not so true. It's a big whitish ball of plasma. It looks yellow to us, orange-reddish at sunset, because the shorter wavelength colors, the greens, blues, violets, get scattered as they pass through Earth's atmosphere, leaving us to see the longer wavelengths of the reds and the oranges. This is often known as Rayleigh scattering. And these are just stunning to me. These are some of Father Secchi's sketches of stellar spectra. Just absolutely impressive detail of the spectra. Father Secchi's section of the moon, right there. Next gentleman on the page is Sir Locke here. The Sir makes you aware that he is a British citizen, and specifically from the United Kingdom. Locke here is the individual that is credited with recognizing that there is helium in our wonderful sun. And the reason we're including the discoverer of helium in our cosmos is because the two most prominent elements in stars are hydrogen and helium. So we definitely want to pause for a moment to look at the way in which astronomers saw helium. They saw it in a spectral pattern of the sun during an eclipse. Eclipses provide the best way for us to see the corona, the outermost layer of the sun, and to get the accurate spectra of that corona. And since I've mentioned helium, I'd like to take a moment here and just point out some of the dangers of helium that people seem not to be too aware of. And helium is actually quite dangerous. It should absolutely not be ingested. So, as it says here, the helium belongs in the balloons, not in your lungs. And I want to show you an accompanying public service announcement associated with ingesting helium.
Take a deep breath. That's fresh, natural oxygen from the air. Oxygen fuels your body and increases your energy. Inhaling helium, however, has a different effect on the body. Many times, people will breathe helium simply because it makes their voice sound high-pitched. Without getting too scientific, helium doesn't exactly change the pitch of your voice. Sounds made by your vocal cords move faster through helium than air. Because helium is lighter than air, it changes your voice's frequency to a duck-like sound. But breathing helium can displace the oxygen in your blood. Not a smart choice. Even 1 breath of helium can cause you to become groggy. You can lose consciousness and collapse. Your body may start to shut down, and your heart may eventually stop. Hey, are you okay? Every breath of helium removes more and more oxygen from your cells, including your brain cells. You cannot live without oxygen. Inhaling helium directly from the tank is especially dangerous. Even 1 breath can cause your lungs to explode. So, while it may seem funny to inhale helium so your voice sounds high-pitched and squeaky, it's really not worth the risk.
And I think it's a risk many people aren't aware of. that the way in which you are ingesting the helium can definitely result in the deprivation of the oxygen from your bloodstream. We live in an era now where if you want to hear your voice sound funny, higher pitches, even lower pitches, higher frequencies, lower frequencies, use your smart device apps and record, and then you can manipulate the sounds to sound like various animals, creatures, cartoon figures, and have the fun with your voice that way. Do not ingest the helium from balloons. It can be quite devastating and fatal. Here we have John William Draper Jingleheimer Schmidt. I'm just kidding. We have here John Draper. All of these confirmed images of John Draper. We all go through various different looks as we go through our stages of life. It's one of the few times in astronomy you want to have both the first and the surname written down in your notes. He was an avid amateur photographer. Being a U.S. professor of chemistry and physiology, he's a little bit more on the wealthier side and could afford one of the new fandangled contraptions we now know as a Kodak Eastman camera. And he's the first person that we're aware of to take a photograph of an astronomical object. So think to yourself, what might be the first celestial body that is captured on film? The moon. And this is a copy of an image that John Draper is credited for taking the first picture of Earth's moon. Here's another rendering of the first image of the moon. The Draper family home is now a National Historic Landmark, not because of the fact that the owner of this home took the first photograph of the moon, but as you'll see, the Draper family has quite a significant place in the history of astronomy at large, and more specifically here in our situation of looking at the way in which stars are classified. And their home is in New York. The John Draper piece of the moon. And here we have John Draper's son, Henry Draper. This is why you definitely want to have the first names to distinguish between the father and the son. So Henry Draper. Similar career passion as his father. His father's interested in physiology, interested on a level of teaching at the college about physiology. And his son became a physician. Also enjoyed the wonderful hobby of astronomy. And as you can see here, Draper applied the field of photography to stellar spectroscopy. Started to capture pictures of the stellar spectra rather than the probably very painstaking approach Father Secchi was doing of sketching by hand the stellar spectra. And here are just a few images of the early photographs of Henry Draper. This right here is an image of the Orion Nebula, so the interstellar cloud at the heart of the belt area in the star pattern of Orion. And the classic expression, like father, like son. This is the first ever lunar eclipse photograph. Another thing you want to add into your notes about Henry Draper is the Draper catalog. Upon his death, which was much younger than expected, he died from pneumonia and complications from some injuries that he had received during the Civil War. He had a will that provided an endowment for Harvard University, which was widely considered and is still widely considered the best astronomical observatory on Earth. And he had left an endowment, which is a large sum of money that is donated to a university. There's usually a provision with the endowment that the money is used to generate interest, and that interest goes to provide scholarships for various programs. The endowment that his wife Anna left for Harvard was that they would take the stellar photographs that Henry Draper had amassed over the years and make some sort of sense out of them, organize them into the obviously named Draper catalog. And as a university, you definitely want to take in as much of donations as you can to keep your programs running. It took about 12 years, so over a decade, but the folks at Harvard did come up with the Draper Catalog of Stellar Spectra, still used today. This catalog is a catalog. It's not necessarily designed for light reading. It's a catalog. It's an inventory of the stellar spectra. The Draper legacy continues with the Draper Award, which is the highest award that an astronomer can receive in the United States. It's kind of like a National Nobel Prize. It's presented by the National Academy of Sciences, which is a conglomeration of the top scientists of the nation, a big think tank perhaps, and the headquarters is located in D.C. And here is the Draper piece of the moon. Or skip one for a moment here and jump to, as we already mentioned, Anna Draper, Henry Draper's spouse, the one that oversaw and herself donated a large sum of money to the Harvard Observatory. She was from a wealthy family herself and was equally passionate about the world of astronomy alongside her spouse of Henry Draper. So you want to add Anna Draper. We have 3 Drapers on this page, hence the reason for including the first names. And she was another huge financial contributor to the Draper catalog and other projects at Harvard Observatory. And so back up here to Edward Pickering. A little bit better photograph here of Pickering for you. And Pickering was the individual who was placed in charge of making this catalog happen. So here's the name you want to jot down, Pickering. And he decided to get the ball rolling, as the expression goes, in saying, okay, we have this great strategy from Secchi, and he had the classification of white, yellow, red, and deep red. Pickering crashed the red and deep red category into one, and Pickering decided to assign letters. You don't need to jot this down here, as the system did evolve. But Pickering, you want to have is the person in charge of the project. Now, anytime a university or any establishment, business receives a large donation, you want to make sure that you maximize the donation and get the most out of the money, quite literally and figuratively. And this is in a time period, 19th century in the United States, where it's actually legal to pay women less than men. And sadly, in some cases in the nation, this is actually still true in the 21st century. But being a good business-minded individual in managing the monies the university entrusted Pickering with, he, like others in his same position, recognized that he could employ women to do the same job and pay them less than if he'd hired male graduate students that were doing research at Harvard as they pursued their degrees. And so he hired women, and they became dubbed the Harvard computers. Now, this is before the term computer in what we think of now as an electronic device that can do a lot of great work, calculations, storing of information for us. Computer was originally a term used to recognize someone who had great mathematical skills. And so when it came time to name the physical machine that we now call the computer, it was a natural transition to think of, okay, human brain, great calculator, to this machine, great calculator, to computer. So they were known in their day as the Harvard computers, very similar to the early African-American women mathematicians who worked for NASA that recently been brought again to the public attention wonderfully by the book and then put into a film format of The Hidden Figures. They were known as the NASA computers. So back to the Harvard computers. This is an image of some of the women and other lead supervisors and associates in the project. This image is nicknamed Pickering's paper dolls because of the resemblance to the paper doll change that are made with paper. You kind of start out the same way as you would make a snowflake, but instead you cut out the outline of a human figure and open it up and you get this lovely chain. Or if Vader were to do it, he might make a chain of troopers. Gotta note the detail of the scissors there. The very famous Pickering paper doll photograph, as it resembles that paper chain of dolls. And just some pictures here of the Harvard computers. Hard at work. This is the spot the difference. With Pickering in the left corner, without Pickering. It's just the different days at which the women would work. And as you can see, what their work consisted largely of was looking at glass plates. So photographic plates originally developed on glass that the women would then look at the detailed spectral lines through these magnifying lenses hour after hour after hour, 8-10-hour shifts with 12 years in the making. So quite the project.